This is the circuit diagram of speed checker to detect rash driving on highways using the 8051 microcontroller with relay. Here we have 8051 microcontroller with standard crystal circuit and reset circuit. This push button capacitor and resistor making a reset circuit here, which is going to 9th pin. The 18th and 19th pins crystal is connected to the 11.0592 MHz crystal. To the microcontroller inputs are coming from the IR photodiode sensor arrangement, which is going to 2nd and 3rd pin of the microcontroller, and the outputs are going to the 16:2 LCD display to display the speed and give buzzer sound. And this relay which is controlling through this relay driver UN2003, and here we have one SPDT switch to change the speed limit from one speed to another, say a 40 km per hour or 60 km per hour. Let's first we see the power supply section. This is our power supply circuit. Here we use the step-down transformer 230 volt AC to 12 volt AC. This AC we fed to bridge rectifier which convert AC to DC. After that we have 470 microfarad capacitor acting as a filter here. Here we get unregulated DC around plus 12 volts. After that we have 7805 voltage regulator output of which will be plus 5 volt DC. We have here 10 microfarad capacitor just to remove in ripples in the supply. After that we have red LED for power indication in series with the 330 ohm resistor. First we see the output components. Here we have a buzzer which is controlling through this NPN type transistor BC547. This emitter is grounded. Collector of the transistor is connected to the negative of the buzzer. The positive of the buzzer is connected to the plus 5 volts. Base is going to microcontroller through 2.2K resistor and fill up with 1 kilo ohm resistor, and also at the output we have relay. This is 12 volts relay. This is relay coil. We have connected our load. Between common no point, this common, this is no, and this NC point parallel with the relay. We have connected red LED for indication. Relay is working in series with 1 kilo ohms resistor. This is relay driver IC. This relay driver IC. First pin of the driver IC is going to the 4th pin of the microcontroller. So one first pin high output will be low. That time this relay will conduct, this circuit will get closed, so our lamp will glow. So when microcontroller delivers low logic from 4th pin, this becomes low, so this is high. So this becomes high means relay will not conduct. This will be get open, so load will be in off condition. Same here for buzzer. Base of the transistor is going to the first pin, so when it's give high, this transistor will conducts, buzzer will sound. When first pin give low logic, that time transistor will conducts, buzzer will be in off condition. Now comes to the input. In input side we have IR LED and photodiode arrangement. Here we have IR LED, infra LED in series with the 150 ohm resistor. This LED continuous through the light in front. This IR LED kept photodiode in series with the 10 kilo ohm variable resistor. The middle point, center point of the resistor goes to the transistor base in series with 1 kilo ohm resistor. The transistor emitter is grounded. Collector point is going to the microcontroller 2nd pin, and this 2nd pin pull up with 10 kilo ohms resistor. Now it function. The beauty of the photodiode is when connected in reverse bias, based on the light fall in it, resistance value will change. Say when fall on this photodiode, its resistance will be less, so voltage drop across will be less. Here voltage less means here at variable resistor voltage will be more, because this resistor and voltage potential divider here, so this voltage go and by this transistor. That time transistor conducts and the collector point will be become a low, so low logic will go to the microcontroller that time. So when interrupts comes to the light, photodiode exhibits the high resistance. High resistance means high resistance drop, so here high voltage drop means voltage will be less, it will not get the appropriate voltage to by the transistor. That time this transistor will not conduct, it act as an open circuit, so it is 5 volts apes here and goes to microcontroller. This is the high logic going to the microcontroller, so when an interrupts comes, high logic goes to the microcontroller. When this is no interrupts comes, low logic will goes to the microcontroller. Same way we have used another set IR and photodiode. One set is for stack point and another set for the end point. So when a vehicle passes from stack point, the timer will start. When it too passes from the end point, timer will stop. So microcontroller will count the time and display the speed of the vehicle. So when speed is under limit, it will display. If speed is out of limit, that time also its display, and the buzzer will sound and relay will conduct. Thank you.